Okay, hello everyone. Thought I'd make a video today. I keep messing it up, so this is like the third attempt on this video, so hopefully I won't make a mistake this time. Okay, first off, I'd just like to say how proud I am of those individuals, which is so many people in the class that are working so hard right until the end. I was really impressed with a lot of assessment grades yesterday, and if you're one of those individuals that feels like you've worked hard, haven't quite got the grade that you want, I'm still incredibly proud of you. Yeah, you've made so much progress over the course of this year, and I hope that you keep it up right till the end. Okay, today we'll be moving on to writing and simplifying ratio. So ratio is a term which is used quite a lot, but it can be a little bit confusing unless you know exactly what it looks like. So if a question asked you, say this was the situation you had, this one red thing here and these three blue things here. If I asked you to write the ratio of red to blue, then I would write it like this, and it's how many reds to how many blues. So there are 1 red to 3 blues. For every 1 red counter, there is 3 blue counters. The order in which that's written is really important. So say it said write the ratio of blue to red, then there would be 3 blue counters for every 1 red counter. It's important that you read the order in which it's said here. Yeah. Now, something else that they could potentially do is if I had this question instead, so instead of this, I asked you to do this. In fact, let's do that on a new page. So if here the question asked you to write the ratio of red to blue, then I would say, well, there's 4 red counters to every 12 of the blue counters. But if I think about it, there is still 1 red counter for every 3 blue counters. There is 1 red counter for every 3 blue counters. And this is what we can do. We can say, instead of saying 4 to 12, an equivalent ratio in its simplest form. Yeah, so I'm going to write that like this. So write the ratio of red to blue. Give your answer as a ratio in its simplest form. And that's going to look like this. Well, the ratio of red to blue is 4 to 12. But because they have common factors, in this case, I'd look to, if we go back to, and this is why this is such an important topic, what the highest common factor of those two things are. So what's the biggest number that goes into both 4 and 12 without a remainder? That would be 4. So if I divide that side by 4 and that side by 4, that will give me it in its simplest form. So 1 to 3. So I can do that with anything. So if I asked you to simplify the following, so if I asked you to simplify the ratios below, I'd be looking at these and I'd say, well, what goes into both 12 and 20? Right. I'm going to say I can't see what the highest common factor is. Say, for instance, I do know what the highest common factor is, but I'm just going to go, well, I can see that they're both even numbers. So I'm going to divide by 2. 12 divided by 2 is 6. 20 divided by 2 is 10. And then I might sit back and pat myself on my back, but I haven't done it correctly, because if there is still common factors that aren't 1, obviously, because that will give me the same ratio, then I should continue to simplify. Well, I can see that 2 goes into both of these. So 2 goes into that, and 2 goes into that. So that's going to give me 3 to 5. This is therefore in its simplest form. Yeah, this is my answer in its simplest form. Now, before I do this one, in fact, let's just do one more, because I don't think my examples have been very good. Say instead you had this one, if you were to simplify, let's say 12 to 30. Let's do even better than that, actually. Let's say we did 18 to 27. So I'd think, what are my highest common factor of both 18 and 27? If you can't see it straight away, don't worry. Just see if you can find a common factor. You might realise that 3 goes into both of them, and then you could do 3 and 3 again. Or in this case, I can see that 9 is my highest common factor. So if I divide one side by 9 and this side by 9, it's going to give me 2 to 3. Any more common factors apart from 1? No. Now, ratios can be expressed with 3 parts. So say, for instance, if I was describing the class, yeah? So if I was describing the class, I might say that the ratio of boys to girls is, and I don't know what the actual answer is, but say there are 13 boys to every 17 girls. That's 2 parts to that ratio. Now, if I said that what's the ratio of teacher to boy pupils to girl pupils, then there would be 1 teacher for every, whatever I said, I can't remember now, 13 boys to 17 girls. So 1 to 13 to 17. It can have 3 parts. So if we had this one here, 3 parts, and those 3 parts were 15 to 20 to 30, I would approach it in exactly the same way if I was asked to simplify this ratio by looking for the highest common factor of the 3 numbers. In this case it is 5, therefore I divide each of those numbers by 5. That's going to give me 15 divided by 5 is 3 to 4 to 6. Any common factors? There's a common factor of 2 between these 2 things, but because 3 doesn't have a common factor with both 4 and 6, 2 doesn't go into 3, this is now in its simplest form. This is that ratio in its simplest form. And this ratio is equivalent to this one. So there's lots of similarities with fractions. Okay. Okay, so hopefully that clears up how to simplify ratio. I'm now going to ask you to do a My Maths activity on simplifying ratio, which I'll put up now. If you could watch this video first, obviously, and then get into the habit of simplifying ratios, and then we'll pick it up again next lesson. I hope that you're well, guys. Stay safe. Bye.